So prior to this, we learned solving systems using substitution. And today we're going to learn a method called elimination. Now, elimination does exactly what it sounds like. It eliminates one of the variables in a way. So if we take a look at number one, remember, when do we want to use substitution? When it's y equals or x equals, and then we can substitute into the second equation. But here we see we don't have that. But there's an interesting thing that we can do with two functions, and that is we can add these two functions together. So if we were to add these two functions together, let's look at what happens. So we add them together, we get negative 4x plus 4x goes away. Negative 2y plus 8y is 6y, and then negative 12 minus 24, or plus negative 24, negative 36. And we can kind of see, we could solve this now for y because one of the variables has been eliminated and we get y equals negative 6. Well, if y equals negative 6, just like yesterday with substitution, we can now say, well, if y is negative 6, we could plug y into one of these. Doesn't matter which one. Let's do the top one. Negative 4x minus 2 times negative 6 equals negative 12. Again, that's because y equals negative 6, so where I saw y, I put negative 6. So we get negative 4x, negative 2 times negative 6 is 12, equals negative 12. Divided by negative 4, and we get x equals negative divided by a negative 6. So our point of intersection between these two graphs, if we were to check it graphically, 6, negative 6. Be careful, the x goes first, even though we solve for y first. Now, it doesn't always work out nicely where we have two coefficients in front of the same variable that are opposites of each other. But if that happens, we can do something to make it so that they are. So for example, let's look at number 9. So when you see number 9 here, we have 5x plus y equals 9, 10x minus 7y equals negative 18. No lead coefficients, or no coefficients, are opposites of each other. But we can do something to one of these equations to make them opposites of each other. And what we're going to do is, and I'm just going to white out this number 9 to make some room here. What we're going to do here is we can, if we do something to both sides of an equation, remember it will stay balanced. So I'm going to take this top equation and multiply the entire thing by negative 2. Why? Let's see why. What does that do for us? Now we get negative 10x minus 2y equals negative 18. Now, with that, and now my second equation, which is 10x minus 7y equals negative 18, now I am able to add these together, and what's going to happen very nicely, the negative 10x and the 10x will go away. Negative 2y minus 7y, negative 9y, negative 18 plus negative 18, negative 36. And now we see that y equals 4. Take y equals 4, go back and substitute it into one of the equations. I'm going to pick the top one. So y equals 4, 5x plus 4 equals 9. 5x equals 5, x equals 1, which means we get 1 comma 4 is where these two functions will intersect. Okay? Now, remember, you want the signs to be opposite so you can add them together. So sometimes you look at a problem and it looks like it's already going to be set up for elimination, but if we look at number 7 here, oh, negative 6x and negative 6x, they're not opposites, but there's a really easy fix to this, right? So I'm just going to set this one up for you. I'm not going to finish it and solve it, but let's set it up. What can I multiply one of these by to get negative 6x and negative 6x to be opposites? Well, let's just take one of them. It doesn't matter which one. I multiply by negative 1. When we do that, the sign of everything is going to change. And I'm going to get 6x minus 6y equals negative 6. The second equation will not change. And now I can add these two together. Okay, guys, so you're going to finish the rest of these problems. I've done 2.5 of them for you. You have 3.5 left.